Hello everybody. Some of you have come to ask me questions about the exam and the exercises, especially for the chapter number 4. So I just want to remind you that in order to solve the problems and find the solutions, specifically for the acid-base reaction, you have to follow the method. So remember, systematically use the method, right? First, unknowns. Find the unknowns. Second, equilibrium reactions. Third, equilibrium equations with the dissociation constant, the K. Fourth, the mass balance or proton balance. And the fifth step is solve it. Taken from the Sawyer book, in the chapter 4, there is a number of exercises. So I randomly picked the number 11, right? So the number 11 says that an ionized hydrogen cyanide, which is HCN, is toxic to fish. So we're going to assume that the toxic level of the hydrogen cyanide for a given species of fish is 10 to the minus 6 molar. So for a total cyanide concentration of 10 to the minus 5 molar, determine at what pH the hydrogen cyanide reached toxic level for ionic strength approximately 0, so that means that we're going to neglect the ionic strength, and then B, when the ionic strength is 0.1 molar. We have an answer here that the first number A, it's 10.27 and B, it's 10.15. If we put the question in a different way, we will find that we need to assume that a toxic level of hydrogen cyanide will be a concentration of 10 to the minus 6 molar. You have to remember that HCN, it's going to be hydrogen cyanide. So without the hydrogen, we're going to have cyanide ion. So the question says that having a total concentration of cyanide, not hydrogen cyanide, of 10 to the minus 5 molar, what is going to be the pH at which the hydrogen cyanide will reach toxic levels? And we know that the toxic level is going to be this concentration. To solve the problem, we're going to follow the method. Remember the 5 steps. Write the unknowns. Next, write the equilibrium reactions. Next step, write the equilibrium equations. Fourth step, do the mass balance and the proton balance. And the fifth is solve it or construct the graph, in this case the pH diagram. Once we have written the reactions and the equilibrium equations, we can find the pH diagram. Remember, pH and PC. We know the dissociation constant of the acid, we know the dissociation constant of the water, so we're gonna draw it here, right? pH, lines for hydrogen, lines for hydroxide, and lines for hydrogen. Now we put a line. What is the toxic level? As the problem states, the toxic level of hydrogen cyanide is -6. Then we have the concentration of the cyanide ion, which is -5. So with this concentration, -5, we get with the pKa the point where the cyanide and the hydrogen are going to be the same. Now we have constructed our pH diagram, and we put it over the system of the cyanide and the hydrogen cyanide. The question was, at what pH the hydrogen cyanide will start reaching the toxic level? But we have the concentration of the cyanide not at the hydrogen. So if we have the total concentration of the cyanide ion, we have this, but we need to follow the acid line to find a toxic level. So at this concentration, we're going to find out that the hydrogen cyanide will reach this point, which is somehow about 10 something. 10.2 is the right answer, and we got 10. That's pretty close.